Welcome in the arena. My name's Allyson Klein, and today we've got a fantastic episode for you. I've got Sanjoy Maity, CEO of AMI, back in the studio with us. Sanjoy, welcome back to the program.
Thank you, Alison. Good to be back.
Now, let's just get started. You've been on the show before last year, but for those of the audience that have missed our last conversation, can you just please briefly reintroduce yourself and AMI?
Sure. So my name is Sanjoy. I'm the CEO of AMI. And at AMI, what we do is we make all kind of platform and silicon firmware, which enables all the compute ecosystem or compute platform, including the complex AI data centers, servers that we see, and up to all the way to edge devices or industrial PCs and everything. Side by side, we also make middleware components for the AI data center physical and IT infrastructure management, which includes cooling, rack, or power shelf, etc. And at the top level, we also have a pod level or a data center level infrastructure management, which is a centralized one single pane of glass view of the entire data center, including all the nodes, all the AI infrastructure component like cooling infrastructure or power infrastructure, etc. So we are a full stack software firmware solution provider.
That's amazing. I invited you back on the program because I recently read a blog that you wrote around management of AI infrastructure being somewhat of a five-headed Hydra right now. And I loved your analogy and I loved what you brought to that conversation. So I thought it would make a great podcast. What pushed you to frame the problem in the way that you did?
Yeah, what I see is in the industry, everybody is trying to solve the same problem. And the main problem is for the mainstream computer delivery, because of the massive demand that we have in the AI data center, how fast we can innovate and how fast we can scale the operation and the deployment of the compute devices. By doing that, the many industry leaders or influencer or technology providers, they're innovating too fast, and there is no time for us to making sure that it is a standard and it is a one version of truth in terms of the implementation, which is actually a problem for the end customers or end users, where they have a heterogeneous components coming or implementation coming from different companies with different level of security measures, with a different level of manageability features, etc. We call it as a fragmentation in the industry, and there are multiple strategic inflection points in the industry because of these technology shifts that are happening. And at the same time, if it is getting fragmented, it becomes very difficult for the end customer or end user to manage the heterogeneous environment. And we believe that that is something to be resolved. And as we are waiting for coming up with the standards and common way of implementation, the gap is increasing. So that's why it is like a monster, like a Hydra that you cannot solve. By the time it's trying to solve, it is again the gap is moving forward, right? So that's why the analogy is, and it is a problem. It is not a problem for the manufacturing side or problem like AMI, let's say, providing different type of solution to our customer. But we as a thought leader, we should have a purpose for the industry and the ecosystem. We believe that this is a problem that we all need to solve as a good ecosystem partner. And this is fragmentation needs to start with. And there are other issues, definitely we'll talk about it. So this was my motivation to write this, to create an awareness within the ecosystem.
Now, I know that we're going to go through each head of the Hydra in detail, but before we get there, can you give us a sense? And I know that you work with partners from across the value chain to deliver foundational technology, but gives you a unique perspective to understand, why is all of this converging now? I know that we're building out AI data center infrastructure, but what is it in that is changing, that is creating this challenge?
Yes. So if you see that, there is a massive demand. The demand was not there before in terms of the compute, usage of compute or training or whatever we say. Ultimately, it's a compute at the low end. The amount of processing that is the demand by the customer and demand by the world is unprecedented. We have never seen that before. It was only for scientific applications or scientific purposes, research purposes. It used to be used, but now we are seeing in devices, even a cell phone or mobile phone in your pocket is so powerful and doing the AI calculation, right? So those kind of demands are pushing the data centers to scale the operation as fast as possible. Now, one single company cannot solve this problem. That is the main problem. It is happening. When we were depending on majority on one company with the GPU to start with for training our AI models, AI is the most fascinating technology and the most used processing power used in the industry today. We see that the GPU has some other side effects, like it is a very power hungry device. It also creates complex environment, and it is only good if you have a massive scaled operation. So now people are looking, and the industry is looking for a smaller scale or target specific AI inference or training devices, which you can think of more target specific custom processing unit. Let's call it XPU. It could be, if it is targeted for data processing, we call it as DPU. If it is targeted for network side of calculation or analysis, we call NPU. So it can be anything. So let's call it as XPU. So in this light, there are many companies are creating this target specific processing unit. That's why it is getting fragmented, and each one has their own way of implementing the processors, own way of managing the security, own way of managing the the security part of it. So all put together, it's very highly fragmented. It's getting highly fragmented, and that is the reason, because the demand versus the deployment, it's a race currently.
Now, one of the things that you talk about is that if we look at these problems, and you describe this a little bit, they're interconnected. They can't be solved in isolation. Firmware is what holds these, challenges together. And I think that firmware, everybody in tech knows what firmware is, but it's not necessarily something that has had its spotlight moment until now. Can you just give a sense to our audience, how we should view firmware in 2026, and why maybe is it finally reaching a point where it's becoming just so much more foundationally important to data centers?
Very good question. So I will give one example with two companies implementation, let's say two type. There are many, but that will give a clear explanation. For example, let's say we are using GPU and CPU in a data center. So GPUs will be used for training a model, and then CPU will be mostly used for inferencing that when you are trying to use it, right? And both are coming from two different companies, and both are managed in terms of power and thermal versus the efficiency in two different ways. Which I mean that the CPU coming from one company can be managed with, there are concept of power capping. Like if the data center believes that this is the best way of using the CPU for the best efficiency and maximum business outcome of compute power at the particular time in the data center, then they have some levers, some tuning that they can do with the management functions for that particular CPU or a cluster of CPUs. In case of GPU coming from a different company, has a completely different way of doing it. Now, if each company starts giving their own way of APIs and the levers, then it is very difficult for the industry or the end customer to fine tune and make sure that in that environment that they can get the best out of the return on the investment that they have in terms of power, thermal, and everything. Correct. So this is where I think firmware plays a major role here, because the intelligence, how to change and how to control a GPU and CPU is actually from the GPU and the CPU. So the firmware resides inside this particular processor unit to start with. Today, it is coming from proprietary built CPUs from different companies. So I would call it as a vertically aligned CPU industry or GPU industry, processor industry. As opposed to right now, we are also seeing there is a horizontally aligned processing industry coming up, which is the custom silicon, where there is a common framework across the GPU, DPU, NPU, XPU, whatever you can think of, right? Those kind of XPUs. And each target specific processor has its own addition. So the common portion, ARM has defined this as a new specification called CSS, which is custom a compute subsystem. And the way that it is built is in the form of chiplets. So now adding more chiplets, we can address each target specific need. At the same time, managing security, power, thermal could be common. So that resolves also many issues in the data centers in the future. But vertically aligned processor economy or industry, we will still continue. We'll still see the heterogeneous management APIs and everything. So we are always trying to solve it outside of the processor. In case of the horizontally aligned custom silicon design, we are very closely working with companies like ARM to make sure that we have the common way of managing it, whoever makes this, to create an ecosystem out of it. So we are putting our firmware inside that CPU. But vertically aligned thing, we are trying to solve this outside of this in our platform firmware, which we call BIOS, which is our Aptio firmware, which is for boot purposes, and MegaRack, which is our management solutions or the firmware. And we are trying to resolve in that level to give a common way of managing from the upper layer.
Mm-hmm. Now, you described fragmentation at length, and you talked about the various forms of accelerator technologies that are going into AI data centers. When does this fragmentation become a real operational risk in your mind?
It is already, and we see, because we closely work with the tier 1 hyperscale data center companies, and we see the massive challenges that they have. And there's a significant amount of investment that they do to mitigate that and put together. But I see the major challenges. My last market report that I read is the growth of the neo clouds are actually 54%. So it is very fast growth segment than the tier 1. They are the one is at risk because of this heterogeneous platform. How they are mitigating is probably right now they are not deploying too much of heterogeneous solution, which is also not efficient for them, because they probably would be using the same GPU for the, sometimes for a set of workload, it will be overkill. So to optimize that, they need heterogeneous solutions, and it is coming. I think that area, the neo clouds will face the maximum challenge for the heterogeneous environment in the future.
Now, security is another area that you call out, and security firmware anchors anything from secure boot to attestation or update integrity, but it's often invisible to the people responsible for defending it. So why is this gap so dangerous as AI infrastructure scales?
Very good question. So I would put it this way, that in the future, when the neo clouds are growing so fast, and each data center will focus on particular set of the cloud services that they will come up. So eventually we will see, for a bigger task, we will depend on a hybrid cloud. And here the security and the attestations comes into the picture. In the high level, everybody understands that the cloud providers has to guarantee or attest the security measures or whatever that we see. And that level, if it is a hybrid cloud, you know that you cannot be a self-certified entity, right? So that means one cloud vendor or one provider cannot say that I'm certifying myself. It has to be certified by third party in case of that. To do that, you need an industry standard way to attest. And if the GPU and CPU and the heterogeneous components are using different mechanism of security implementation, it is a problem. So the industry is heavily motivated right now, and the big implementation towards the standard like Calyptra, which is a silicon root of trust, which solves the problem of a common way of attesting it, so you don't have to self-attest. For example, a CPU manufacturer cannot say, okay, I am self-certifying my CPUs for the memory access, for my security of my processor by the same company. It has to open a common APIs and common way of third party to attest that. So that is, we believe, is the main big challenge that we will see in the future. And of course, the firmware plays the maximum major role here, because firmware has to expose the security measurement and during the secure boot and all these phases, even at the runtime. That is the platform firmware plays a maximum major role here.
Now, what I thought was really interesting in your article is that you then went into power and thermal, which a lot of people don't think about in terms of IT administration, but there is something really interesting in play in AI data centers in this space. Can you talk about why there is an integration of power and thermal into traditional IT stack management and what the future holds here?
Yeah, absolutely. This is the most complex subject today in front of us, and the reason is, so far we dealt with computing, which is typically a binary algebra or that kind of subject that we know, and we controlled it for a long time. And the CPUs and GPUs, or the processor or the compute environment, was producing heat, which was under air cooled management for a long time. It's very easy, right? But when we are looking at the future designs, which is the massive amount of heat dissipation and thermal management is required, those kind of things are not easy to manage. At the same time, what happens is the processors are getting bigger and bigger in size. When it is getting bigger and bigger size, there is so much you can do cooling per square millimeter area. When a GPU is large size, because of the chiplet design or multi-die packaging design, putting more cores, that means one side of the chip will be different temperature than the other side of the chip. And you are actually flowing, the cold liquid in one side and bringing the hot liquid back from the other side. But you don't know what are the other portions of the chip is having what level of the temperature. And that happens because inside the chip, there are typically 96 to 128 or 256 core. Not all cores are running at the same speed. They are actually isolated in different cluster. It's called GSP. Let's say in case of GPU, it is a GPU service processor. And each cluster within the chip is running workloads. If one portion is running high workload, that will be hot, correct? And if we don't cool it down, then the entire chip will be shutting down. This is a typical phenomenon of hotspots that the chip will have. So I'm talking about multiple complex problem here, which is based on the thermal flux, right, and thermal wall, this kind of problem. At the same time, the liquid properties, which is cooling down, which has different dielectric for different, coming from different companies, coolant. So every time the management firmware or the controller which is sitting next to that GPU to control it needs to know the dielectric properties of the coolant, which is coming from a particular company, the flow, how the the pump actions and the how the flow of the liquid, needs to know the hotspots, needs to know actually the workload running isolated on the isolated GSPs, and then it has to go back and manage it, right? So now I will talk about something called closed loop management of this thermal. Now, closed loop management means now the rack previously we used to see one rack full of compute servers. That's all, and the servers will be in the middle portion of the rack. Bottom probably will be power supplies, and top will be a top of the rack switch to connect the rack to the network. Now this whole compute rack is disaggregated in three. One is the compute, and which contains the GPU and CPU rack. Second is dedicated for cooling purposes, cooling rack. And third one is dedicated for power, which is power rack or power cell. Now, when we have disaggregated things, now each rack is coming from different vendor now. Previously, we used to buy the full rack of servers, including the cooling arrangement of air-cooled devices, together from one company. Now it is coming from three different companies, right? And it's sourced. Now, these companies, they don't work with each other. And whenever there is a workload given by the data center administrator to a particular server, that server is getting hot, but that has to be cooled down by the cooling rack, which is coming from a different company. Their management controller is different. So imagine the how fragmented and heterogeneous the manageability is. So what we are trying to do is trying to make sure that we follow the same standard. And at the top level, at the middle level, we have rack manager in each rack and working with each rack providers so that we can manage them properly. And at the top level, data center level, we have an infrastructure manager which can tie all of them as a single pane of glass to the system administrator. But the subject is very complex. So that used to be liquid and pump and everything used to be part of the data center facilities. Now mechanical, electrical, and plumbing, which is all put together is the cooling and all these things, are shifting. The manageability is shifting from the data center facilities to the IT. Because IT has to control, because that depends on that controls the efficiency of the server as well as the token processing as well as the business of the whole data center.
What's fascinating about this is you wrote about fleet scale, and I think that really puts it into perspective. I mean, AI data centers are not one rack; they're football fields full of racks. I think that one question that I had for you is, as you look at the scale of these implementations and all of the challenges that you've talked about thus far, what breaks first if the control plane isn't consistent across that infrastructure?
That would be very difficult for anybody to manage, because how do you get the cooling? So let's say from the top level, I'm a system administrator. I want to maximize the token processing per watt. That's how my scorecard is, and I am measuring my business. So that means I need to know what is the efficiencies. It's like a sports team, right? You need to know the strengths of each player and distribute that game strategy. And it's nothing different in a data center. So now if you want to do it, and if you don't know exactly the characteristics and the manageability strengths of each rack and each thing, then you will not be able to distribute this workload to the servers properly and run this business. So that means you need one single way of managing compute rack, cooling rack, power rack. There must be common industry standards which has to come up to the top level infrastructure or pod level management, where the system administrator can give either programmatic interface through that or graphical interface or whatever way it is, but it has to be a common way of managing these three racks. It cannot be disjointed effort, and it has to be closed loop, meaning if a If a workload has been given, it has to be cooling down properly. Then it has to be, the cooling rack has to work in conjunction with the compute BMC or the management controller that we have. All has to work lockstep. Otherwise, it will not happen, right?
Yeah. Now, the final thing that you talked about is mission criticality of this. And I think that, we've seen hyperscale data center outages, and we've heard about some of the challenges of the manageability of these massive clusters. Can you talk about downtime in these types of environments? And, can we even bound what that would cost an organization?
Yeah, I mean, I know there was we know from the reports from the market that the AFR, which is annual failure rate of AI type of servers or the GPUs, are 11%, where the spinning drive, which is the most vulnerable or most I would say the error prone device in a data center, is 1%, less than 1%. Now, it is not because of the GPU failure, it is because of more complex situations. And so the RAS, reliability, availability, and serviceability, is a big subject that and a big focus for AMI also to solve this problem. One, I mentioned about the hotspot in a large GPU type of die or a processor, where it cannot be cooled down as fast as possible, and there are multiple places having a higher temperature than the other places in the chip, and that brings down the entire chip down, right? So these kind of failures will happen unless we have a feedback loop and unless we have a mechanism to control it. There are many other RAS areas, memory RAS, and then also we see the DRAM controller failure, which is the predictive analytics that we do sometimes and provide the telemetry data. But we, from the firmware side, provide the telemetry data upwards. But somebody in the data center administrator level should take the decision. Even when we are talking about cooling, we cannot also cool down the servers too much. If we do cool down the server too much, then there will be condensation happening in the rack, and that will also kind of shut down these systems in a hyperscale environment. So you see that subjects are not easy. It's a very complex subject. So I would say that reliability, availability, and serviceability are in multiple areas. One is the GPU, CPU itself, where the way that we manage the thermal and power, and the way that we manage the high-speed interconnect and interfaces. It could be UCIe, it could be CXL, that kind of interconnects. How do we predictive failure analyze the DRAMs or the high-speed memory, HBM, those kind of things, as well as the storage. All put together, the telemetry and analytics that we continuously do, we provide tons of data from our out-of-band controller to the upward that is available to do analytics. And that should be the base of the RAS, controlling the RAS and increase the reliability of the entire data center eventually.
Now, one thing that I think is really interesting is that there's a lot of proprietary solutions out there that say that they're going to help with this. But, one thing I liked in your article is that you say that, they're quietly adding to the chaos. Why hasn't that worked, and why do we need a different approach?
So our goal is to defragment whatever activities are going on. So everybody's trying to solve problems, and they just do, the solutions are coming. There is a different way of solving this problem. But at the same time, it also creates fragmentation on why it is a problem, right? The problem is, for example, if we have a solution doing out-of-band management type of solution for power and thermal, and if you don't have the transparency to the entire ecosystem and the world, then nobody knows how to do a security test on that particular solution or implementation. Nobody knows how the what are the patches that we need to apply. It's always depending on individual implementation. So what we do at AMI is we come up with all these innovative ideas. The standards are very important to us. So we are engaged with OCP very much, and OCP is putting together a lot of work groups, 5 or 6 different work groups, which is the AI infrastructure side of it, including the ORV3, which is Open Rack V3, modular system hardware V3, and we are continuously contributing the proof of concept as well as the standards that we are contributing to the standards. Not only the POCs and the standards, we also open sourced our major platform firmware to OCP. So we have the best and maximum transparency about the implementation. So this is where we believe that we are differentiating ourselves than the other solution providers, because we want to do it with transparency.
Mhm. Now, you've been in the firmware business for over 3 decades. And how does that history position AMI differently for this moment?
It's actually 4 decades. We celebrated 40 years.
Yeah.
So yes, definitely. We started as a proprietary firmware provider, as an independent firmware provider, of course, in the ecosystem. But we see ourselves differently now, because think of the way the industry is moving, the pace, and the way the innovations to be done. It cannot be done with a proprietary firmware anymore, because you will be hurting the ecosystem. And first of all, I mentioned so many different parallel technologies. It could be coming, 30 years ago, we saw only one company who is providing CPUs, and pretty much 100% of the industry was using one processor, Intel, right? Today, it's not like that. Today, there are so many other companies that are coming with different architecture. How the industry will move forward fast unless we have a transparency and we have an open source and open architecture concept, right? So that is where we have also evolved. And I would say after 40 years, we have evolved a lot. Now every firmware or everything we do, our idea is first open source in our mind. We do not think of proprietary things at all. And that is how we are evolving today. And in the future also, we'll be continuously growing in that way.
That's awesome. I have one final question for you, and it's kind of a high-low. If the industry doesn't really rethink how to approach firmware as a foundational layer, what are we risking? And conversely, what does getting this right unlock?
If industry does not think that firmware is important, the main problem would be it's like you have a house, you locked everything, but you are opening your basement door open all the time. Nobody cares, nobody looked at it, but it starts from the firmware. Everything that a compute hardware wants to provide. So firmware is the main enabler or configure or manager of the hardware that we see today. So that will be definitely a major issue. I don't think industry is looking that way. Industry has a lot of attention today on the firmware. We see that all the time. And we continuously are working with all the industry influencer as well as the leader, key silicon provider. As a matter of fact, for the custom silicon designs that I talked about, there we have partnered with ARM, I mentioned, and together with not just the ARM, there is a set of companies part of the ARM Total Design
Sure.
ecosystem, and we working together to build a new ecosystem, silicon ecosystem, where these firmware problems will be solved. So not even that I have a very high confidence that the industry is definitely emphasizing that a lot.
Yeah, ARM is doing such a fantastic job building that chiplet economy with their ecosystem, and I'm so glad that you guys are a part of it. Sanjoy, it was such a pleasure talking to you today. I learned so much every time I get the pleasure to have you on the show. Thank you so much for your time today.
Thank you.
where can the audience learn more about what AMI is doing in this space?
We have, I would encourage all our customers and partners and viewers of this podcast to look at ami.com, as well as we are deeply integrated within OCP. And please take a look at our OCP contributions and the work that we are doing together. And there's a lot of good things happening over there, solving all these 5 problems that we discussed today.
I can't wait to have you back on the show. Thank you so much for your time today.
Thank you, Allyson, and thank you to be here. And it's a great pleasure talking to you every time.